Okay, here is the video for our test review um, for our intro to trig. So in this first section, we are converting from degrees to radians or radians to degrees. Remember, you'll be multiplying either by pi over 180 or 180 over pi. Remember, you're trying to, okay, well, here's what I'm trying to say. If you're starting with degrees, you want pi in your final answer. So multiply by pi over 180. If you're starting with radians, multiply by 180 over pi. That way the pi's cancel. There'll be a pi in top, pi in bottom, and they'll cancel. So since this is degrees, I want pi in my answer. I'm going to multiply by pi over 180. Simplifying these fractions, 36 over 180. On my key, I divided both of them by 36. But you don't have to recognize 36 as a common factor. You can divide by 2, and then by 2 again, or then by 6, or by 3. Just keep going until you can't anymore. And at some point, you'll end up here, pi over 5. Negative 820 times pi over 180 is negative 41 pi over 9. So remember, 820 over 180, just simplify, divide by 2, divide by 4, divide by anything you can think of, divide by 10, just over and over and over until you get to a place where you can't anymore. And 345 times pi over 180 is 23 pi over 12. And if you look at the key in your Google Classroom, I have my steps for simplifying in a little more detail than I have right here. Number 4, we're starting in radians, and we know that because it begins with pi. We're trying to convert to degrees, so I'm trying to get rid of the pi. So I multiply by 180 over pi. So a pi in the numerator cancels with a pi in the denominator, and then I just do 4 times 180, which is 720 degrees. 7 pi over 9, we're going to multiply by 180 over pi. 9 goes into 180 20 times. My pi's cancel, 20 times 7, then multiplying across is negative 140. And then here again times 180 over pi. My pi's cancel. I can cancel these zeros because I'm basically dividing by 10. 3 goes into 18 6 times, and now 13 times 6 is 78 degrees. If you're not comfortable canceling in the problem like this, what you can do instead is just multiply your numerators, multiply your denominators, and then simplify the resulting fraction. For this next section, numbers 7 through 15, you can just read these values off of your unit circle. Remember, when you see a negative angle, that you're going to start at 0 and rotate clockwise to find that angle. If you have a positive angle, you're going to start at 0 and rotate counterclockwise to find that angle. So just take a minute and pause your video, do 7 through 15 with your unit circle. All right, here are the answers for 7 through 15. If you want to pause your video again, just so you can check them. For 16 through 21, we're dealing with reciprocal functions. So for example, cosecant is 1 over sine, or 1 over the y coordinate at pi over 6. So you'll just find the y value at pi over 6, and it's 1/2. And you're going to take the reciprocal of it, which is 2 over 1, or just 2. Cotangent at 150 is the reciprocal of the tangent value. So the tangent value there is negative rad 3 over 3. So you're taking the reciprocal of that, which would be, and you don't have to flip the negative each time, you can just leave it out front. So the reciprocal is 3 over rad 3. We need to rationalize the denominator. Multiply the denominator by rad 3 and the numerator. Multiply numerators, denominators, and we get negative rad 3 over 3. This 3 over 3 simplifies to 1, so my final answer is negative rad 3. On 18, secant is 1 over cosine, or 1 over whatever the x value is at 210 degrees. So you're going to take the reciprocal, which is -2 over rad 3. Okay. All right, so that is the reciprocal of cosine at 210. Now we rationalize the denominator. Multiplying across the top gives me -2 rad 3, and multiplying across the bottom gives me 3. Always, if you can, these numbers outside the radical, the 2 and the 3, if you can simplify that fraction, do. We can't here. And by the way, just to make it clear one more time, when I say we're taking the reciprocal, like cosecant is 1 over sine, right? So the sine of pi over 6 is 1/2. And the reciprocal means we're just going to it's technically 1 over 1/2, and we're going to keep the numerator the same, change to multiplication, and flip the bottom fraction or take the reciprocal. So it's really 1 times 2 over 1, or just 2. So pause the video and try these bottom 3. And these are all negatives. So remember to, you know what, hold on one second. Let me get my unit circle and show you something. All right, on this one, we're being asked to find cotangent of -7 pi over 4. So this is 1 over the tangent of -7 pi over 4. So -7 pi over 4 means to rotate in a clockwise direction that same distance, which lands us right here at positive pi over 4. But instead of thinking about it like that each time, here's a shortcut. Find the positive version of your angle, okay, 7 pi over 4, which is right here, and reflect it over the x-axis. So reflecting it over gets us to here, pi over 4. And then we find the tangent value there, which is 1, and we're going to do 1 over that. So 1 over 1, which in this case just happens to be 1. For number 20, it's cosecant -3 pi over 4. So cosecant is the inverse of sine, so 1 over sine, -3 pi over 4. So it's going to be 1 over the y value. Sine is the y value of the ordered pair at -3 pi over 4. So I'm going to go to my unit circle. I'm going to find the positive version of 3 pi over 4, which is right here. And I'm going to reflect it over the x-axis. And it lands at 5 pi over 4. So the y value there is negative square root of 2 over 2. So technically I have 1 over negative square root of 2 over 2, which means multiplying by the reciprocal. So you're really just going to take this and flip it. So 2 over rad 2. You can keep the negative in the bottom, top, or out front. They're all the same. So now we rationalize. And I've got -2 rad 2 over 2. And this is where we do have a fraction that cancels. 2 divided by 2 is 1. And my final answer is negative rad 2. So you pause and do 21. So secant is 1 over cosine. So -225. Find the positive version. Positive 225, reflect it over the x-axis, gets me to 135. And cosecant is, or sorry, cosine is the x value. So -2 rad 2, or -2, sorry, I'm trying to hurry. Negative rad 2 over 2. We're going to take the reciprocal, which means to just flip that. So that's going to give me 2 over rad 2 negative. rationalize, and I have negative 2 rad 2 over 2, or just negative rad 2. On the back, we are trying to find cosine of theta if we know sine theta is 2 over 3. So here's where we're using our trig ratios. Cosine is x over r, sine is y over r, and we have this quadrant restriction on our angle. So this is between 0 and pi over 2, so that's our first quadrant. I'm going to draw my triangle here. X I don't know, r is 3, y is 2. I'm going to use Pythagorean theorem to solve for x. Taking the square root here gives me positive or negative 5. We know it has to be a positive 5 because from our drawing, x is in the positive direction, so I just need positive 5. And now I can find the cosine is x over r, square root. So rad 5 over 3. You pause and try and do number 23. All right, on this problem, our domain restriction was from pi over 2 to pi, so that gets me in the second quadrant. And after I draw my triangle, it makes it clear that x needs to be a negative value because it's in the negative direction. So after I do Pythagorean theorem and I get down here to the square root, it's either going to be positive or negative rad 40. According to my drawing, it has to be negative. And so then I just simplified my radical to negative 2 rad 10. And this is my x value. Now the problem's asking me to find tangent, which is y over x. So y, I got from the sine ratio, y is 3. And then I have 3 over my new x value. I rationalize the denominator. Rad 10 times 10 is 10. 2 times 10 on the bottom is 20. Now you take a minute and try this next problem. All right, so I've drawn this picture here. We were given that tan theta is negative 4/5, and we know that that is the trig ratio of y over x. So the question becomes, well, which is negative, the y or the x? And we figure that out by our domain restriction. Our angle has to be between 270 and 360, which is quadrant 4. And so in this quadrant, x is always positive and y is negative. So that's how I know y is negative 4 and x is positive 5. So I use Pythagorean theorem to find r, square root of 41. R is always positive. So now I have r, x, y, and I'm going to use my trig ratios to figure out the rest of these. So go ahead and pause and you figure out those. All right, pause the video so you can take a minute and see I have written out the ratios. Remember that secant is an inverse, so you're just flipping the answers that you already found and rationalizing the denominator where necessary. All right, and on this last problem, we are given a point, -5, -12. We need to find r, and then using Pythagorean theorem, and then we need to set up our trig ratios. So you pause your video and try that. Pythagorean theorem to find r, and then trig ratios to find all these values. And by trig ratios, I mean y over r, x over r, y over x, like that. Okay, so alongside here, I used Pythagorean theorem to find r, which was the square root of 169, which is a perfect square, so that's 13. So I have these values, x is -5, y is -12, r is 13. And then if you want to pause so you can check everything out, I've written the trig ratios for each of these. Remember that if you have a negative over a negative, that simplifies to a positive number. And then these are my reciprocal functions. 1 over sine means flipping the sine ratio. So instead of y over r, and we now have r over y. Similarly for 1 over cosine and 1 over tan.